I would like to present to you just preliminary results of maybe future project about the methods of layout and reconstruction of regular and medieval location in Central Europe. And the aim of the project is to verify the methods which were already used in this kind of analysis, but with additional data which just come during a time, because this method which I will talk about, they start to use in the 60s. And then to apply another method which never been used before in analysis of in urban scale, usually in very small scale, like architectural detail or just a small object. So to explain the main idea of the project, I will ask you to imagine that you are a surveyor hired to plan a new town in the middle of nowhere, using only a rope and stick. It is possible that the effect of your work will be visible after hundreds of years. And some people using available methods and some new technologies will verify how accurate you have been. And this is exactly what this project is about, is concentrate in Silesia region, which now is showed on this slide. And these two methods will be analyzed on two case studies from Namysłów town and Dzierżoniów. So something about the regular towns in Central Europe. In West Europe, during about 3 centuries, the pattern of regular town were developing. Gradually, we can observe the merge of regular elements like a rectangular square, some regular plots with regular dimensions. But till this was very much optimized and simplified, you can see how it's developed. For example, here in the first phase of town planning, in the beginning of the 13th century, we can see some regulation in the town planning, but they are still very extended, and the frontage of plots are very wide, not so much shorter. And then you can see during the time, still in the 13th century, that they are become more to the square dimensions, not like before. And here we can see, like in the second half of 14th century, the town planning became very regular, like in the town which we are now, in Krakow. You can see that the plan becomes 9 blocks layout with central market square. But the Central Europe, the pattern of regular town planning, developed quite independently based from the West Europe, based on the local experience. And what is very good to say that in this 13th century, the pattern was developed and established in the newly arranged urban settlements of Central Europe. So, how to reconstruct the layout of medieval town? The thing is this: the most commonly used method, since I already said in 60s, called modular analysis or metrological geometric analysis, allows to reconstruct the parcellation basing on the model, a unit of measure, confirmed in written sources. So firstly, we have to already assume what kind of unit was used. Amongst the lengths of basic objects on the town's plan, a pattern of round multiplication like 50, 100, 150 of unit like a foot length were searched to establish which measure system was used to a planning by medieval surveyors. Having established a base measurement system, the whole plan is fit into a rope length grid, recalculating the length of the multiplication of the rope lengths. The modular analysis method was quite widely criticized because of this rounding data, because of the errors resulting from inaccurate measurements of some historical plans. And that's why we consider it to check it once again and maybe to apply another method to verify what kind of unit and sister measurements were used. Of course, what kind of limitation we have? Basically, we are talking now about the errors, inaccuracy of medieval layouts. So the guys who are just measuring the city make some mistakes, and it's not also from written sources that sometimes this mistake was even 1 unit. So like they mistake 1 foot. So maybe it can be hard to find out statistically how it was done. And of course the tools which they used, like a rope, it's not very fixed tool, and impact of the terrain, and sometimes this can use some, I will say, not regular measurement, but to fit to the terrain. And of course, there were later changes in the town layout. So we are now quite a lot of time from that period which the town were established. So the thing is, if we still see what was the first division of the town. And of course, there are some inaccuracy in measurements. There were considered as what kind of data we use. For this case studies, for this just preliminary results, we used cadastral data. So in this case, they already in the borders of plots or the borders of each parcel, there is about 10 centimeters. That can be 10 centimeters error. Another problem with reconstruction of units of length, that is, maybe we know something from our written sources about the system of measurements, but we know that there were few of them. Like in Silesian towns, the historian of urbanism said that there were 2 foot standard. Rhenish one, which is about 0.31 meters, and Chełmińska foot, 0.28 meters. And then this whole system was multiplied, and we get 2 foot as a cubit, and then a rod and rope. So if we can establish a basic unit, we can just assume what kind of system of measurements were used. And it is worthly to say that this in laser Poland, so like for example in Krakow, the system were by this modular method were already done. So most of the towns were analyzed in this way in 1670s. So after, if we're still talking about this modular analysis, after we already established what probable food standard were used, we have to, the second step is just to fit this modular grid to the town plan. And of course, there are some very important elements in the town which the grid should be fitted to. And that's why we consider it as a main square, frontage of plots, the gates which actually outline the old town. So when we try to fit this grid, like geometrically, we have to just focus on these elements. So maybe you don't see very well, especially the one which are very far. But here are the 3 proposals of grid, which are based of The first one, it is based off the foot, which is 0.29, 296 exactly. So it's like close to the Roman foot, because it's also said that in some towns they can use also the foot which comes from the ancient time. And another foot standard was 0.28, is this in the middle. And the last one was this Flemish one, 0.31. And when we just geometrically check it, we orientate and locate this grid on very important elements of the town. So you can see that the frontage of the north elevation of the main square and the west elevation is like an orientation angle. And the rest, we can just have to observe the elements of the city, which can fit to the grid or not. So there are even, in some cases, in some elements, there are very small changes, but in others, the difference shows that one of this grid fits more than another. The same thing we did in Dzierżoniów. There are also the same free grid models. And you can see here, these colorful borders are the borders of the fortification. So we should consider the grid just inside these borders. And once again, we put all the grid together. And what we can see, what's happened in this city, that probably when it was measured first time, they just measure a circle inside, like that one here, just to this point, but regularly. But then it was some part of the city which still have houses and have plots. And when then after they put a fortification, they include this part to the whole area. But before, they wanted to have regular pattern around. Yes. So how to detect medieval, actually the value of parcel division? Our case study is one of the plots which probably has a medieval origin. So of course we can know that from the archaeological sources and from the architecture and layout of the city. And the best of course is to choose the main square, because in the rest of the city, usually the war damage cues the situation that the new buildings were built and you see nothing about the parcel division. What is also important, that width of the front elevations is not the same with the width of the parcel division. So I just skip it to show you that here, for example, you can see the grid with the red color, but the parcel division is not exactly sharing the grid, just inside the division was inside the parcel. We said that we try to use another method to check if another approach, we don't assume what kind of food unit were used, but we just wanted to check based on the set of measurements what was the unit. We use a cosine quantogram method, which were already used before. And here you have algorithms which were applied in R by my colleagues. So if you wanted to find and check maybe your data, you can find in this address, or I can show you later because it's not very visible. And yes, so basically this is what actually equation a function is about. And the cosine quantogram method, in case of medieval town planning, is you have to think about it like each parcel dimension can be described as a integer m multiplied by a basic unit q and plus some error q's by the things which I told before. And the value of q, which maximizes the formula within a given range, is the one with the highest probability of being a true quantum. So the first case study, Namysłów, which we first try to understand how the parcel looks like and where were the medieval division, how it doesn't look. And I just have a shorter time, so I will not explain a lot. But we, of course, use the historical data, how the parcel was before in the past, and then we reconstruct this. We used first the data, which were already calculated by this modular method. And unfortunately, I don't know for exactly for who, but by this method, it shows that 0.25 meters is actually a quantum for this data. But the one who analyzed this by the modular method, which this geometrical one, said that it's 0.31. So they just don't suitable to each other, but they are the same data. And then we try to check if this kind of data are suitable for that method. So we recalculate this. We recalculate foot to meters, and then the result was good. So it just means that so much rounding a data, doing a collecting and then changing to the foot standard, just makes huge error. So when we analyze our data from the master plan of Namysłów, we get good results. I mean, the one which can be assumed that it was a Rhenish foot standard, and we get half of the Rhenish foot standard, 0.155. And then we get some verification of results by bootstrap confidence intervals. And in the simulation and the confidence interval 95%, the range is just within. So we can say that there can be maybe not mistake, but we can't be sure because as you see, there are some additional quantum candidates. And the same we did for Dzierżoniów. And the result the same?
Have to stop.
Yes, okay. Sorry.
Sorry, there will be no Dzierżoniów. Sorry.
Okay.